This group is a difficult group because we have, I mean, like four, or me included, 5 panelists here, and with very, very different backgrounds. So Mihai and myself, we are, oh, sorry. So we are some people from the academia, like Alex and Massimiliano, and then we have Johannes here with a critical systems background, and Mihai and myself, we are from the cyber field. And we are going to talk about AI. And when I was thinking about the opening line, it wasn't easy to come up with a good summary. But for that reason, let me start with a quick intro round. So I would like every one of you to come up with a very quick introduction, just describe us how you encountered AI, LLMs, Gen AI, or whatever you want. So how you encountered that the first time? What was your... So when did you understand that this is going to be something that's new and that's shocking and that's different? I don't know where we start. Maybe let's start with Alex because he's online. So let's start there.
Okay. Hi. Can you hear me?
Yes, loud and clear.
Okay. Yeah. Okay. So I'm Alex Salai. I'm a Bloomberg Distinguished Professor at Johns Hopkins, and I've been running the Data Science Institute for Johns Hopkins for the last almost 20 years. And recently we are getting involved in a big way in AI. And so we are in the process of hiring 110 faculty just dedicated to AI at the university. And I'm the lead in the infrastructure side of that project. And I have a professorial appointment both in physics and in computer science. And my involvement with this started about 30 years ago when we got into a large sky survey project, which generated an unprecedented amount of data, and Hopkins got into the archiving of this data set. So this was our involvement in big data. And then there was a straight pass, to everything computational in science. So my first encounter with LLMs was, so we built the archive, a SQL archive for our data. It is now almost a petabyte of astronomical data. And when the first language model started to appear, one of my colleagues showed me that, okay, ask anything about your sky survey. And I said, okay, I ask, a typical question that extract me all the galaxies which have this property. And amazingly, it actually understood our database schema, and it wrote a very comprehensive and almost accurate SQL query. And this was in the early days, so I was completely blown away by, the information it had to digest. And now I'm spending essentially almost all my time on AI-related things.
Yeah, thank you, Alex. Johannes, would you go next?
Well, more than happy to. I started reading AI concepts in the 90s in my university days. It was all theory back in the day, and I proudly built my first computer by hand, and of course nothing that you could program came even close to that because the computing power was not there. So I've been looking at the Sleeping Beauty for 15 years, 18 years, and I was totally amazed when computing power then allowed the first language models, the first real machine learnings, and that's how it evolved. I was critical about the idea that we would really come to the point where computational power, according to Moore's law, is evolving to a sort where it came, but it happened. So we were in 2015-16. We were building the first predictive models for logistics supply chains on actual events. So we gathered unstructured data from the internet. In these days, Twitter was still open. So in countries in Africa and Asia, people use Twitter to tell about a roadblock or a police blocking or. So we collected all these data and tried to make out the possible route changes for DHL trucks. So that was amazing. It was unparalleled. We had to use neural networks, of course, because we had no other forms of how to develop it. But to play around with that and to see that it comes into life was amazing. That was my first encounter, building that root and risk platform.
Yeah, thank you. Mihai?
Probably I am one of the non-scientific people in this room. So I was always working with cybersecurity, so security questions and cryptography, where we see already new challenges due to AI. And actually I faced it years ago, but in the last 2 or 3 years we started to deal with. And we already try to use it day by day in the practice. So we live from revenues. So we have to have revenues. We have to collect people. We have to train them. We have to work and to make different engagements for different clients. And we see spaces where it's a very good tool, and I still await the miracle. So it will come in 1 year or 2 years or 5, I don't know.
First encounter with LLMs? What did you do?
So around 3 years. So
what did you do with it?
First I was using EY's tools and then ChatGPT, and since then we try to be familiar with several others as well.
Okay. Massimiliano?
So in cybersecurity, I've been working in cybersecurity for the last 14 years. And my work in cybersecurity has been more on the modeling side, using mostly graph theory and a lot of work on metrics. So I never had the need so far to get into AI, ML, or anything of that sort until a couple of years ago. And that involves also Balazs and Newpush, because we were running an NSF IUCRC, Industry University Cooperative Research Center, and Newpush was one of the, among others, one of the member companies. And so 2 years ago, when we were about to wrap up this project and thinking about the next chapter and of this, I came up with the idea of focusing on infrastructure security. So I wanted to create a next generation center on lessons learned from the previous one, focusing our security efforts on critical infrastructure. And I remember, pitching this to the board at this meeting in Colorado, and the industry board for that center said, "You need to bring AI into the picture." Because this is where everybody's going, and there will be no security without even considering the role of AI. So that's where we came with the idea of a center in infrastructure security in the era of AI, which we are trying to establish as a new NSF ICRC center. But as you probably know, NSF, as many federal agencies in the US right now, it's experiencing significant funding cuts. So we are trying to figure out a way to reinvent ourselves and to survive, through these difficult times. But going back to the role of AI, it's clear that we need to integrate AI and security, because we are facing adversaries that will be increasingly using AI to automate attacks. And we need to level the playing fields. We will not be able to face these threats without using AI for defensive purposes, because otherwise we'll not be competing on the same fields with our adversaries. So I'm very interested in how AI can support security in two ways. One is, of course, defensive, by creating tools that leverage AI to automate and speed up our ability to defend and adapt to adversaries, but also use AI to understand how attackers are operating, how they're using it. So by knowing better what they're doing and how they're using AI, we can be better prepared to respond. Years ago, we did a more than 5 year project, MURI-funded project on the concept of cyber situational awareness. And we understood that in order for you to have effective defenses, you need to understand two things. One, you need to understand what you are defending. You need to understand the infrastructure that you're defending, its vulnerabilities, the dependencies, but you also need to understand the attacker, what they're aiming for, how they're operating, what their motives are, and so on and so forth. So it's a two-sided problem.
So this is a bit, I mean, we geared towards AI and security as a topic, so let's continue there maybe, and then also address the challenges in academia with regards to AI. And what you mentioned is the use of AI when securing ourselves, but what about AI security itself? So how to secure AI models? What kind of guardrails are there? And
yeah, that's a very good question. In security, there has always been this notion of security perimeter, and in the old days, it was clear what the perimeter was because systems were pretty much well defined within the confines of a company, of an organization. So everything that was inside was good, everything that was outside was potentially bad. Now, over time, with the new waves of technologies, that boundary between the inside and the outside world has been eroded. And I think the first major technological innovation that contributed to eroding that boundary was cloud computing. Because all of a sudden, companies started to outsource significant portions of their operations, whether through infrastructure as a service or platform as a service or software as a service. But the bottom line is some of the operations were being moved to another provider. So now that provider became part of the attack surface. There was no perimeter anymore in the classical sense. And now with AI, it's a similar problem because when we say, okay, companies are adopting AI, what does that mean? They're using AI providers that are, again, residing on a most likely cloud infrastructure or a computing infrastructure which is outside of their premises, it's off premises. So we have the same technical issues we had with cloud computing in general. And on top of that, there is an added piece to the attack surface, which is the data and the models.
So supply chain is
right.
basically
But essentially, if you're relying on AI to do part of your defense, an attacker could compromise your security by compromising the data that you're using for training, compromising the model. So what this translates to is that you now have a larger attack surface. You don't have to just protect your infrastructure. You need to protect the AI models and protect the data that is being used for training.
Sure.
To prevent poisoning that could lead to making the wrong decisions down the pipeline.
Absolutely, great points. Johannes, you.
And that is a very important point that you're making because the shift from, there is this bad Portuguese script kiddie trying to hack my financial applications or sending me phishing mails has completely shifted into combined hybrid attacks by organized groups that are really trying to get your silverware. That's a game changer overall. That complete states are now trying to destabilize physical infrastructure, energy, and not only using code, which partially is AI generated, which we can prove, but also using drones, using physical attacks. So really starting a hybrid war against infrastructure, that's a total game changer. And that has changed, I think now in 25 dramatically. I mean, even today, the Munich airport is down due to Russian drones over it. It's not funny anymore. And the Berlin airport is down due to a cybersecurity attack. So
not to mention JLR, right?
Huh? JLR, yeah, totally different ballgame. They closed down the whole factory until
for 3
October.
weeks or so. Yeah.
So that is, it's having a multi-billion impact. And funnily enough that you're mentioning it, the Pat Vaughn, the former CISO of the US Army, he was telling us over and over, it's not about the perimeter defense anymore, because and you exactly make the point, it's not able to define the perimeter anymore. So don't think about that. Think about how you're getting back on your feet once you took the hit. And that seems to be the much more advanced point of strategy that you would be using now to see, how do I save my data? How do I protect the data model? Yeah? the Chinese and Koreans are working on server farms, how to spill large language models with crap data in order to force bias on it.
But let's assume for a moment that the AI is benign, okay? So it's not been poisoned, it's working as intended. What are the risks in that case? I mean, I still see AI supply chain as a, we are trusting companies. It's a very concentrated trust. So what can possibly go wrong with that? I mean, let me give Mihai the word just for a moment, because
I think in this case we have to take the typical supply chain risks, and so who wrote the model, who was feeding it, what do we have originally from it? If I talk to someone, is it a real person or not? How we realize that it's an AI pattern or not? But coming back a little bit, because I heard several very good sentences already at the beginning from the Obuda University, when we are talking about, when the colleague was talking about how the life is changing, or what you say that script kiddies are not away, they changed with AI to real danger, so they can attack several victims parallelly. So everything is changing, and I was wondering that I work with cybersecurity day by day working methods, and nowadays OWASP top 10, or if you see the typical vulnerability patterns, everything has changed. So I see my colleagues, and we run after the technology, we run after AI, we try to use AI because attackers also use it. And especially 2025 is a totally different year. So we cannot use the old methodologies at all. And we were talking also in the break, and I thought that we have, for example, financial institutions who order afraid of attacks, what they suffer day by day, on the same applications every second month. Mm-hmm. And it's still not a solution. And it's a supplier appliance who obviously doesn't give the source code to the financial institutions, because they could give it to 30 different financial institutions, because everybody is using the same application. And until we cannot achieve that clients understand that the whole life has changed. We were talking. So we had the deputy CEO from Granite Bank, and he was talking about fraud questions. So maybe you have read, at least in Hungary, that Giro has introduced from 1st of July this anti-fraud tool, which was I tell only things which were written in the media. So it was introduced or developed by Telecom, and we were actually working on it as well as quality assurance from security part. So everything went smooth. We have 5 seconds for instant payment in Hungary, up to 20 million forints, which means that if it disappears, then you will never see it again. So then we know that majority of the financial institutions, they do not have any such applications. Therefore, centrally it has been decided by the National Bank, and from these 5 minutes, the minimum threshold, so the maximum threshold,
5 seconds.
A half second was given from 5 seconds to turn back the suspicious.
So half a second to decide whether something is fraudulent.
So and then, since then, there were 3 months to collect the data for AI, and now the AI application, which was delivered by Telecom, now started to work. Mm-hmm. To sort out patterns. So the whole life goes this way, and And I am sitting here as I would understand something, but I have to tell you that I see it probably on one hand from my perspective, which is a daily work perspective, and I always try to hear new things, but I don't know what will happen in January.
I mean, we get tremendous amount of
The more
speed.
you learn, the less you know.
Exactly.
We get tremendous amount of speed and capacity with AI, I think. But I mean, just to continue on the cyber theme, I mean, again, let's assume that AI is benign. We are building it into all of our solutions. I mean, I know.
It's an assumption.
Yeah, but let's assume for a moment, okay? There is a lot of concentration in this field. I mean, how many big providers of AI are out there? I mean, we have just seen that, I don't know, NVIDIA invested over $100 billion into OpenAI the other day. I don't think many other organizations will get the same set of funding. So in that case, are AI companies a new risk or a new angle of, potential risk? Alex, can you maybe add your thoughts about that?
Well, so actually, as I was listening to the discussion, there was one other thought that occurred to me. So basically, there is this extreme agility in this field. So that the different technologies, the new technologies leapfrog each other every 6 months. And we can see it on the way the drone warfare is, for example, emerging, enabled by AI, that a single individual can buy basically a state-of-the-art drone, but to deploy defenses over a large attack surface takes basically a governmental scale involvement, which requires a year to deploy the technology. So that guarantees that the defenses will be always 2 generations behind. So is this actually a challenge? That how can one actually bridge this challenge? That okay, so the defense will catch 99% of the attacks, but there will be always in the tail a few attackers who are using more advanced technology than the governments and the defense is based upon, even if it is happening on the scale of OpenAI. Because if they want to deploy 100,000 GPUs, then there will be always somebody who can buy actually the next generation, as 1 or 2 of the next generation GPU and use it basically for an attack. Mm-hmm. So what do you think?
Janis, will you add some more thoughts?
This is an excellent point, and it feeds into the how do you get back on your feet once you took the hit? Mm-hmm. Because the lack of definition of the parameter on the one hand side, and the idea that that once you stumble, you really lag behind in the race for the technology. And we're seeing that in Germany on a massive scale in the lack of drone defense that we have. So we're working on it, and we're using hefty AI models in order to catch up with that. But we see once you try to start in the middle of the race, you have to catch up. So it takes a lot of money, it takes a lot of effort, and it takes a lot of brain to get onto that train then. Mm-hmm. We've been discussing that last night, right?
And to your point of getting back on your feet, there is a formal definition, a formal framework of doing that. It's called cyber resilience. So we are moving, or we should move from the traditional approach to cybersecurity, which is mostly trying to prevent, okay, which does not always work, to cyber resilience, which includes anticipating, responding, recovering from, and adapting to change. So we need to anticipate, and that's where probably AI could be the most useful, because it can help us understand patterns. It can help us interpret data into the context in which things are happening. But we need to, again, anticipate that some of those attacks will eventually be successful. We will not be able to prevent all possible ways an attacker will try to attack us, especially when we are dealing with nation states and very resourceful attackers. We're not talking about script kiddies. We're talking about other states. We're talking about criminal organizations. We're talking about political activists that are trying to create big disruptions. So yes, we need to respond, but we need to anticipate the fact that some of those will be successful and have strategies to recover from those. There have been examples of ransomware that have disrupted entire organizations because they did not have sufficient plans on how to recover data if their primary data sources were to be victims to a ransomware attack. So if you have a serious plan where you anticipate those kind of things can happen, you could simply say, brush it off. I mean, somebody is locked your entire data repository, and you say, okay, forget it. I'll just wipe it off and rebuild from my backups, which were kept updated to the last 5 seconds. So I'm going to lose 5 seconds worth of work. I mean, this is a bit extreme, but that's the idea. We need to be prepared.
I mean, preparation is key. I think we would all agree to that. But I would just try to go back to the ground level for a moment and be more practical. I do think that AI is not a magic wand. Okay.
No, it's not.
So an AI cannot do more than what us humans can do. Maybe it can scale better, it can be faster, but it will not, get information out of thin air. So what I would go or steer the conversation is, there are still tasks and, things to do so that AI works better. I mean, like collecting data and maybe make sense. I mean, make sure that it's complete and it's fine and dandy.
Yeah, this has been discussed already, earlier this morning. But the question is AI a tool? Is AI a technology? Is AI intended to replace humans, or is it intended to work with humans? And my take on this, and we have several pending proposals. The idea is AI is indeed a technology. It's a very powerful technology that can be used for improving the throughput, improving productivity if used correctly. But it's not yet mature enough to replace humans in certain tasks, especially in the security domain. So we did recently, in the last few months, as part of a project, we did 40 interviews of CIOs, CEOs, and one of the questions was, would you like to automate some of your security functions? And the overwhelming majority of those people said, yeah, eventually this is where we're trying to go, but we don't trust AI yet to make these decisions. Mm-hmm. So you cannot completely leave decisions when we're talking about security to an automated tool, because AI can make mistakes. And you don't want an automated tool to make decisions that could have more negative effects than benefits without any kind of human supervision. So far, the most promising approach, based on not just my opinion, but on the opinions of this, different groups of people, is to have AI as a partner. In fact, there is a proposal that we submitted on this idea of co-teaming between humans and analysts, where human and AI agents, where the AI agents would be treated as a sort of apprentice who work closely with the humans, but at the same time learns from the human analyst, because the human analyst will provide constant feedback to the AI agent by judging the work done by the AI agent, by judging the recommendations and providing feedback whether those recommendations were accurate or were completely out of place. And having the agent learn from this process.
And I think there is one point that we need to go a little bit more into the detail, because assuming that AI is benign, which I doubt, but that's a totally different story. Because what we know what AI is not is it has no empathy. So it can do face recognition, so it can say if you're
simulate empathy.
No, yeah, but that's the point. Face recognition software can tell you if you're angry, sad, if you have certain sicknesses, rah. The quality of the analysis is almost perfect, but the machine never knows what to do with that until you tell it what to do with that. A machine never has intuition. So it will follow some sort of pattern that it receives that humans might not understand, So it looks like magic how they derive their decision. But once you can go through, it's always a mathematical way. This is not intuition. Humans have intuition, which is a totally difficult and complicated
but
field.
isn't just the question of numbers, how many?
No, it's not. Okay. No, it's not. Definitely, there is a lot of research going on to try to understand what the difference is. It has not come to an end, but empathy, curiosity, and intuition. If you put these three into the race, you might find that slight, that thin division between what the machine can do and what it not can, and where humans should be in control.
So my next question would be about responsibilities, but let's give Alex the
so you know, we talked about what is AI, and in many ways it is actually probably the biggest disruption that has ever happened in computing. So computers up to this point have been fully deterministic. So I took the same code and ran it on a different platform, and still the result was exactly the same. It was fully reproducible. I take a deep learning, I take a neural net, train it on a set of data, then it will give on a certain input, it will give a certain response. I take another neural net, train it on the same data, it will not give the same result. It will be stochastic. So computing suddenly moved from deterministic and reproducible to something which is randomized. And this is a very deep disruption. It happened in physics 100 years ago when quantum mechanics appeared. Mm-hmm. And it completely disrupted the community. So basically, it was the 20-year-olds which embraced the idea, and then the 50-year-olds were scratching their heads to understand what's going on. And lo and behold, look at who is writing the most interesting papers on AI. It's the 20-year-olds today. So it's a fundamental change, and the implications, we have no idea where this is going to lead. But it will be. It changed. Computing is changed. Period.
So the engineer asks me. The engineer inside me asks whether AI is a random generator at the end or not. But anyway, so what about responsibility? Is AI an apprentice? If it is, we are going to entrust AI with decisions going forward. We already do. And who is responsible for those decisions?
Well, if you don't...
Yeah.
You will always be responsible for what you're doing. So if you let your Tesla car decide to run over a red traffic light, it'll be you in jail, or Elon Musk having a problem, but never the car will not go to jail. So liability and responsibility cannot shift. The questions whether you trust a machine about your financial decisions, or should I call my mother, or should I go out when it's a hailstorm, that's your responsibility. If the AI tells you, hailstorm, not a problem, go out. Don't take cover. So it will always be you in the end of days. That's what I believe.
You made an excellent point. AI should be treated as an advisor as much as anyone else. You ask for advice before making a decision. You made the decision based on some advice, whether it's a person, whether it's a machine.
Okay, so I think we...
There's a question.
Sorry, go ahead.
I'll give you mine.
Thank you very much for this inspiring discussion. Critical infrastructure and AI. Imagine that we are sitting here in the Munich Security Conference, where the room is full of the prime ministers and the presidents. What would be your message to them on the critical infrastructure and AI? And if it would be call for action, for which action would you call?
if I may, if you don't mind, the first thing that I would say is think about data autonomy. Think about the value of your data and how you protect them. That's the first thing. The second thing is, would you let a machine take a decision for you that you don't understand anymore and that you cannot reproduce? So transparency in decision making will be one of the core fundamentals for using AI for the future. Because especially when you look into the direction of the Palantirs and the whatnots of the world who are doing thorough analysis which will decide about the life or death of people, it'd rather be transparent and it'd rather be in a way that people can work with that responsibly. That would be my major take on the Munich Security Conference.
What I would say shortly is don't wait until it's too late. Because one thing that is inevitable, if you look at how infrastructure is designed, and in the US there is this agency, it's called CISA, Cyber Infrastructure Security Agency, which essentially is in charge of protecting critical infrastructure. And they came out with the definition of 16 critical sectors: water, energy, nuclear, and so on and so forth. But the interesting thing about these different sectors, if you look at the definitions, they are interdependent on one another. So energy is not a sector by itself, but other sectors depend on energy, like transportation depends on energy. Manufacturing depends on energy. You compromise the power grid, there will be cascading failures on many other sectors. So we need to understand, first of all, what we are dealing with. And in today's world, everything is interconnected across domains, but also we have moved toward this idea of cyber-physical systems, where systems that were normally air-gapped, they were purely mechanical systems, completely isolated from the rest of the world. Now, anybody in China, anybody in a foreign country can hack into a computer system from the comfort of their house and disrupt physical infrastructure in another country, because everything is interconnected. And when the complexity of the systems grows, we kind of lose sight of what we're dealing with. And it's very common to see, disruption to a computer system managing the reservations of airlines. The whole system shuts down. You're not able to fly a plane because you are not able to verify who is supposed to be on that plane. So we need to act before the day we will have such a major disruption that the world will come to a stop just because we're not prepared. So that's the message for the people in charge of running the world, running the countries. And then leave the technical people, leave us, academia and industry to figure out the solutions, but give us the mandate to help solve these problems. Invest in innovation.
Yeah. Most definitely.
Thank you, Massimiliano, for this great segue that you offer me to give a question, because I wanted to go back to this great panel. I want to take Alex back to memory lane about 7 years ago. You were showing us a massive database. Earlier, when you introduced yourself, you kind of mentioned that you're into data science, but I think people cannot, by those words, imagine the size of the data you're handling. I think back in the a decade ago, you were already handling dozens of petabytes of data in relational databases. For those of you who that means something, and you were kind enough to take a look at what we were doing, at some point, I don't know if you remember, but you told us, well, guys, do you guys know what you're doing? And we're like, well, Alex, now that you ask, like maybe we don't know the answer. and you said, well, you guys are building the ontology of cybersecurity. And you gave us such a clarity of what we were unconsciously doing. You allowed us to take it to the conscious level that we since then relentlessly pursued that. And you allowed us to be like a David that could come up against Goliaths and in enterprise environments, show to really big players how it's done. But the reason I'm talking about this today is, and that ties back to our moderator, so you're going to have to talk a little bit about that too, is in most areas today, we don't have stewards of ontology. And most of the topics that AI is unleashed on, it's unleashed without a proper ontology. It's unleashed without a proper understanding of the data. And my question is there a chance of us being able to work on some mechanisms that help people with building ontologies either on the fly or somehow help them with that? Because you certainly helped us, and I was wondering that with these new tools, do you have something in mind that could help?
I think it's happening. So because I can ask questions to ChatGPT or Claude or whatever to kind of collect a lot of data in a particular domain, which is in different formats, in different forums published. In some of it is in papers, others is in books, others in other part of the data is in blogs. And it's in all different contexts. And I think today, actually, the language models are becoming smart enough to figure out the context around the data items, to figure out their meanings. Effectively, they are building their own ontologies. They don't express yet it in a way that it would be easy to comprehend or would match the data models or so. But I think they find the correlations, and this was where the transformer technology was so important, that it was starting to look for long-range correlations in the corpus of data. So I think this is kind of in my mind it's a done deal. It's a solved problem, but we are too dumb to understand how they organize the data to some extent. But it would be important. So these are some of the things that I think we as scientists will also have to do, because scientific data and the ontology for scientific data is also much less advanced than we would like to be. And it would be nice if actually the AI would build these ontologies for us in a comprehensive fashion.
But do you think the humans will agree with what is being presented by AI? Because I see the different forums and I still see the same decades-old problems that the sales department defines customer differently than the support department, and they still define it differently than marketing. And how can we leverage AI to bring them on the same page?
Ask them to explain to the other. So put a prompt that explain to the customer division.
I mean, maybe we shouldn't solve social problems or organizational problems with AI. I mean, that's where we are there for, right? I mean, if all aspects of life is becoming AI enabled, and we are going to use robots to fix our electricity and plumbing and stuff like that. So we should still see our role in that society, I guess.
But tell us more about it, Balázs, because you have also informed our thought process on this huge amount of data and how we make sense of it. So I asked Alex about how to structure the data, and you are more on the completeness side.
Yeah, I mean, we talked about a bit that when I asked about going to AI is not a magic one. We need to give it data and garbage in, garbage out. I mean, those kind of sentences or statements are all true. And I do believe that databases or inputs or contexts or information that the AI works on needs to be in a format that is not right still. I mean, we were talking about petabytes of data stored in relational databases. I don't think an AI would be, with its token counts, with its scale right now, just turn that into something that's a really great data source to do the analytics on. But
I have a thought on this. Somebody already mentioned RAG, Retrieval, Augmented, Retrieval, Augmented Generation, and that is sort of like going back to the basics, because first generation of LLMs were just producing garbage, text. You teach somebody to speak English, to put words together, and it can produce something that is grammatically correct, but it doesn't make any sense, right? The first time I asked, in earlier version of ChatGPT, that I asked about myself, who is Max Albanese? And he said, he's a professor at Purdue University. Where he got it from? So maybe that there was some base of information in the training data, some web pages where there was some mention of me being a professor at a college or something, and it just filled the blanks with something that was reasonable, statistically speaking and semantically and whatever.
And then the random generator.
But it was just random, right? Now, of course, it's more accurate because we went back to the basic and say, we cannot just generate random stuff. We need to ground it in facts. So let's go back to do more traditional kind of stuff, right? And the problem with the solutions that was mentioned is the randomness, okay? Is that randomness a result of something on which you can have different opinions or you can phrase it in different ways and still be valid, or it's just because it's random stuff, okay? So we will never be able to rely on AI until we have results that are random, that are not explainable, okay? And I will give you an analogy that is completely outside of this. So in the US, there was a trend to move elections to voting machines, okay? And states started to adopt voting machines until they realized we cannot trust them because there is no proof. Once we want to do a recount, there is no way to trust the results because we have no proof of how people actually voted. So states like Virginia, who had moved to voting machines, went back to what? Paper ballots. Because with paper ballots, if there is any question about the legitimacy of results, you pull back the boxes with the paper ballots that people have voted on, and you can recount them. And that piece of paper tells you how the voter voted. If the vote was purely electronic, the only thing you have is an electronic record saying that somebody voted for this candidate. Is that true? Or that record was altered even before it was recorded into the machine? There's no way to tell. So now, everybody's going back to paper ballots. So sometimes you go down a path and you realize that it is a dead end and you need to take a step back and do things in a more traditional way that can give you some confidence in the results. So I think with the AI, there's a lot of hype. Everybody treats it as a magic wand, the holy grail that can solve the humanities problem. But maybe we need to take a step back and rethink some of the aspects and some of the way in which we are using it.
Yeah, I mean, would you add 2 and 2 using an AI? I mean, can you do it? Yes. Should you? I mean, deterministic calculations may not apply as easily to AI. We can do it sometimes, but the randomness actually kills the purpose. So, so maybe AI is not for everything, and digitalization is not for everything, like the voting example you just said.
Right. But this is I'm sorry.
Another signs that, in addition, for example, to RAG, that some models are going back to more traditional ways of doing things. There are some specific types of prompts which will result in, under the hood, ChatGPT generating Python code that then processes what you need to process. So essentially, it creates a deterministic way of answering your question. So it translates your prompt into...
That's the point. That's the point, exactly.
Yeah.
Because what the question you're asking will have a totally different answer if you talk about child education, because a child needs to know what 2 + 2 is, and it needs to be able to determine how to sort 2.5 frugal pupillion minus 9. They need to do that because your brain is the muscle that you're using that with. But beyond the understanding of how you model it, how you use the model, and what is the expected result of the model, you can trust a machine so far as long as there is a deterministic approach behind that. When it goes beyond that, you should be really, really skeptical about the result. Give me proof of that. Give me the evidence of that. Tell me how you approached it. So, and a lot of AI machines are not able to do that properly.
Mm-hmm. I mean, the best, one of the best things AI can do is excuse itself, right? When it makes
in poetical ways.
Yeah.
Maybe a practical example. So, you know, we have this NIS2 regulation, which is funny because we still use old but still existing different standards. So we are using ISO 27000. We are using this NIST 800-53, which was taken in Hungary. And as registered auditors, we decided that, okay, let's have a tool where we sort out from written texts the controls. And the unfortunate in this situation that we have 1,400 questions per electronic information system, which all of them have to be answered, and it has to be reasoned. Mm-hmm. And we already using the CERT LLM. We tried out everything, and it's not able. And we are battling for 10 months. Simply we cannot achieve a level of trust where we say, okay, then we achieve 90%, humans can make more mistakes than 10%, then okay, we accept it. It's not working simply. And all the others who are registered auditors face the same problem. We are not able to use it. We can use it very nicely for spear phishing attacks, writing
incident reports,
phishing emails and everything. It's really a nice variety of possibilities, but immediately where it has to do something, it doesn't seem to be very complicated, but probably it's still too complicated for the AI.
So checking on the time, we don't have much left. So as a final question, and I would open that to the audience as well. So what would you take home from this discussion? Is there anything you learned or a new insight that you would take home from here? Alex?
I think what I learned most is actually the difference. So basically the resilience, the word cyber resilience. I wasn't as familiar with it, and I think I'm going to think a lot more about it. And also how to implement, what is the implication also for scientific data, because it's only a question of when will we be hit with a cyber attack that attacks our data sets. So,
Great point. Johannes?
That would be my point as well. A thing that is coming out for me very clearly today is, with all the reactions from the different participants, is that there is a 360 on the perception of what AI can do for us. It can be a tool, it can be an ontology, it can be anything for us. But out of this comprehensiveness of understanding, how do we protect it? How do we protect our civilizations against the intoxication of language models, which is on the brink of happening? So protecting academic data, protecting the industries is a tremendously important point, and that's one of my key takeaways for today, that we have a mile to go there. From identity to the questions of hands-on cybersecurity that you're talking about, into a resilience model that requires a sort of comprehensiveness.
Yeah, very simply, so already on at this stage we need some new approach to security. So everything has already changed.
Yeah, that's a fair point.
For me, the bottom line is we have a lot of work to do, and we need to be more realistic about how AI is going to be integrated in everything we do.
Mm-hmm. Anyone from the
Actually, one more thing came to mind. So about 2 years ago, I heard Yuval Harari give a talk about the emergence of AI. And he started his talk with the dramatic sentence, "The operating system of the human race has just been hacked."
And I really like that point, so that you pointed out also. Yeah, for me, the ontology thought, I really like that. That's a good articulation of what we need to do with all the data we already have and that we might want to use for RAG or for AI purposes going forward. So that was for me. Anyone from the audience? Questions to the panel? Yeah, there is one.
I think you quickly mentioned you think AI is ethical. Is it what you said here when you asking questions?
I mean,
I misheard?
I said that let's assume that AI is benign. So yes, ethical and...
Okay.
Well, it depends on us.
It remains an assumption.
That's just really curious because I'm interested in, and ethical is a human-centric concept. If the AI start to understand whales' language, they might learn their ethical framework. And for example,
by itself, is not a thinking, is not a human entity that has sentiments or empathy or wants to hurt somebody. It's just a very complex machinery. And I think there are a lot of people today they use the term AI very broadly. So for somebody outside of our fields, some very complex, now we have very complex software, very complex software that is baked by mathematical modeling, okay, which may still be very much deterministic. It's like models, for simulating the movement of satellites and other things. They're very complex software, and I feel some people tend to refer to very complex software they don't understand as AI, just because it's so complex, they think there is something magic behind it, but maybe it's very deterministic. But going back to your question, no, the AI is not ethical or unethical, it's how we use it. Most commercial LLMs have some guardrails to not answer certain queries. Or if you ask, for example, we're doing a study on election misinformation. So we asked ChatGPT to generate a data set of fake tweets, claiming election fraud, and ChatGPT refused to do it, right? Because this model has been trained to be politically correct and so on and so forth. So this is how we train them. But of course, there will be models that are used for nefarious purposes, which are not commercial, they are not following the rules, whatever rules we decide they should follow. And those can be used for whatever purpose you want. And there are so many very bad applications of AI already. Just to mention one, the generation of deepfakes, which will have going forward, will have a significant impact on a number of different things, from elections to financial fraud. You can generate a phone call, from somebody claiming to be a relative of yours. It's very credible because maybe they took samples of that person's voice, they recreated message, and that person calls you, he's in trouble, he needs you to wire some money right away. You hear his voice, you recognize the voice, you wire some money, and you just given money to a scammer. So there are a lot of nefarious applications, but it's the humans who make it unethical use of the technology. It's not the technology per se.
I think the topic of automatic ontology build-up came up during the discussion. A while back, 10 years ago, I wrote a paper on how RDF is at the center of building automatic ontologies. So what has happened with the adoption of the RDF framework? Anyone on that? Because that could be the answer to build an automatic ontology that the semantic web can learn automatically by building those ontologies.
I don't think that idea of semantic went too far, to be honest.
Yeah, that's my question.
When I was a postdoc, many years ago, it was very popular. RDF was popular. They were talking about semantic web, about as the holy grail for making web pages intelligible to machines. But I don't think it went too far because it relied on others to adopt it.
Correct.
And to build website using that technology. So it relied on people, Yeah.
There's one point I would like to add. I think it took a different turn because if you're thinking in the direction of ontology, it doesn't work for many, many reasons. If you try to use it for data extraction and interpretation, so you have a legacy database with crude formats and whatnot, you could use a humongous data integration project, build an ETL engine around it, or you use a data abstraction engine, which basically puts these data values into semantic values, makes it interpretable, and doesn't touch the source system, which is quick and price effective. But trying to build an automated ontology from that is a totally different ballgame. Horses for courses, I believe. So,
I mean, that's a great conversation. I would love to join, but what if we continued that as a part of the hallway session? Because I think our time is up. So thank you very much for the conversation and the discussion. Alex, great to have you here.
Thanks for having me.
And thank you for your great questions. So thanks.